The human body is made up of trillions of cells, and think about how incredible this is. We have the ability to take something like this, a piece of food, and deliver it to each of those trillions of cells. That's just ridiculous to think about. Now, the food we eat doesn't just provide nutrients or fuel for those cells. The molecules found in the food are also needed to build new body tissues, repair damaged tissues, and even sustain chemical reactions. So how does our body actually do this? Well, we're going to take you on a little journey from mouth to anus and show you how each segment of the digestive system performs its critical role in breaking down the food and getting it into the bloodstream. And I want you to think of something really cool. Even though your digestive tract is broken down into multiple segments, it is still just one long tube from the beginning, the mouth, all the way to the end, the anus. And we'll even talk about what ends up in the toilet today. And for those of you that have watched our channel before, today we're going to do something a little different. We're going to take you on this journey with students that were actually here in the lab. We've included some of their questions, you'll see some interactions, but hopefully you learn as much as they did. So please let us know what you think of this format. And if you're new to the channel, welcome. I'm Jonathan Benyon with the Institute of Human Anatomy, and we're about to jump into some digestive anatomical awesomeness. So let's move on to the digestive tract. And it is one long tube, everybody, no matter what. And if you all want to stretch it out by the end of class, we can prove that. But one of the things that we just need to think about is the first part of the tube, we really just kind of think of it as the esophagus. Then the esophagus enlarges, we call it what? The stomach. Then the stomach shrinks down. We call it duodenum, jejunum, ileum, which all make up the small intestine. Not small because it's short, but because it's diameter, right? The small intestine is like, I got to get really long for surface area, and we'll talk about surface area in just a minute. And so it coils up like crazy in all the available space in the abdominal cavity. Then it enlarges a little bit, and we change its name to what? The large intestine, and we can break it down into like specific regions as we go. The large intestine has a really specific orientation, right? Just kind of the picture frame, and we'll go over that as we go into the digestive tract here. But as we do this, like I mentioned, let's trace an Oreo cookie from mouth to whatever's left over in the toilet. And I think it's kind of fun. And I want you to think of two words, please. Let's think of digestion versus absorption. What's the difference?
Well, digestion is like breaking it all up.
Yeah, so we got to break it down before we can absorb it. And when we talk absorption, we're actually talking absorbing it into the body like the bloodstream. Technically, the inside of the digestive tract is not truly inside the body yet. Can you all kind of wrap your head around that? Because think about, like, if you stick a scope in to look at the inside of the stomach, that scope doesn't really like get inside the body, right? Even if you do like a colonoscopy. Yeah, in theory, you're like, could we take a string all the way from mouth to anus? I guess in theory, if we could get through the sphincters, we could potentially do that. But with a colonoscopy, we go through the whole colon, large intestine. If people need to look at the stomach, the doctors can send a scope down that way. And you don't get the scope truly inside the body until we absorb into the bloodstream. So does that make sense? So where does digestion begin? In the mouth. How? Mastication is a fancy pants name for chewing. Awesome. And then what did you say? Saliva. So we actually get mechanical and chemical digestion in the mouth. Now, even though we're going to say digestion versus absorption in each segment of the digestive tract, it doesn't mean it's just black and white. Mostly digestion happens in the mouth. Can we absorb a few things in there actually? Sublingual medications, sublingual glucose. If somebody's hypoglycemic, you can put some sublingual glucose underneath there to get it absorbed pretty quickly, but primarily digestion. Now then we move it back to the pharynx because this is a really good Oreo cookie. And the only exception to our digestion versus absorption rule is kind of the esophagus, because the esophagus is mostly just transporting it from mouth down to where? Stomach. Now you will see an esophagus with Misha, but because the heart's in the way, it would run right anterior to the vertebral column, and then it pierces the diaphragm and then balloons out to that cute little organ right there that you can see in pink.
Is that where it goes? It's like the cardiac sphincter?
Yeah, so some people call it the cardiac sphincter, some will call it the lower esophageal sphincter. That's between the stomach and the esophagus, and everybody can see the stomach right there in pink. You're welcome to touch it if you'd like, but I always joke around with my students, and I'll say, like, Remember when we were all trying to get out of school as little kids? What would we try to say to like mom or dad? And we'd go like, my tummy hurts, right? And we'd hold like down here. And technically the stomach's up here on the left upper quadrant, right? So if I ever have a little kid that tries to get out of school with me and says, Daddy, my jejunum hurts, I'm like, you can stay home from school because you know your anatomy. And that's, I don't care if you're faking. So, yeah, so my jejunum hurts. So, but with the stomach, what do you think? Primarily digestion or absorption? Digestion. Chemically?
Mechanically.
Both, right? So stomach acid will start to denature proteins. There are some enzymes in there that can also break down some of the food. And then it's a mechanical blender, a muscular blender. You kind of get these waves of peristalsis in the stomach as it's mixing it up. And we changed the name of food to this word that's kind of funny. We call it chyme. And eventually when it gets broken down a little bit more, we can pass it through the sphincter. And if you actually feel in here, everybody, you can feel it. You can feel the muscle getting much more robust right there, and that's the pyloric sphincter if you want to feel that. The pyloric sphincter means gatekeeper. It always reminds me of the original Ghostbusters. I don't know if any of you are original Ghostbuster fans, where he's like, are you the gatekeeper? Or I am the keymaster. Oh, anyway, I'm a nerd. So I just want to take a quick break to let you know something that we are extremely excited about, and that is we have launched our Institute of Human Anatomy community app. For years, I've wanted to create a place where people could learn even more about the human body, and this app has allowed us to do just that. The app includes exclusive courses, quizzes, and access to me and the IOHA team where we can interact and get your questions answered about the human body. Not only will you be able to interact and get questions answered within the community, but I will also be doing weekly lives where we can dive deeper into specific topics based on many of your questions. Another incredible thing about the app is that it is designed for you to connect and collaborate with other people, such as fitness enthusiasts, healthcare professionals, anatomy and physiology students, and any other anatomy nerd that is part of the community. You'll be able to bounce ideas off of each other, share and learn from other people's professional experiences, and more importantly, apply your knowledge about the human body to health, fitness, and longevity. Or in other words, helping you and the people you know to live longer, healthier, and happier lives. So if you're interested in joining our community, be sure to check out the link in the description below. And now, back to the digestive system. Now, we already mentioned that when we move from the stomach through that pyloric sphincter, we now move into the small intestine, which we can have 3 segments here. Let me just show you some cool things here. So if you look here, there is the duodenum, the beginning of it right there.
And that's like the first 12 inches?
Yeah, it's 12 finger breadths actually, so even less than 12 inches. That's one of those names that I'm like, how did anatomists come up with this? I just picture like a whole bunch of anatomists around a body, a cadaver they've just dissected, and they're like, what should we name this? And one of them just randomly walks up and goes, 4, 8, 12, duodenum. And it's, or whatever. So now I want to show you another relationship here. If I slide some of this other tissue out of the way, you can see the pancreas right there. Let me get my hand out of the way there. But there's the pancreas.
It is.
Yes, it is. So you can touch it. Just be really gentle with the pancreas. So here we have the head and then the tail coming down right there. Yeah, so that's all of it right there. If this body had it, yes, but it was removed on this particular body. Yeah.
I lost mine.
Did you?
The gallbladder?
Yeah.
I don't know.
I love how she said she lost it. Like it, it just fell out. It just fell out. But yeah, so I'm guessing you had surgery.
There's a few things in my body.
Yeah. And so one of the cool things, let's review the pancreas. Why is the pancreas so cool? You learned that it's both an endocrine and an exocrine organ. Now with the digestive system, it's going to act as an exocrine organ. But let's review some of the endocrine functions because that's going to be on your big test as well. So if we were able to look at some of the cells in the pancreas, we'd see these clusters that they call the islets of Langerhans, and those cells produce insulin and glucagon. Does everybody remember what insulin did? Yeah, so we essentially say insulin lowers blood sugar. So if we eat some carbohydrates, which we just did with our Oreo cookie because there's lots of sugar in there, right? We're going to have some glucose in there, probably even some fructose, but fructose actually gets converted to glucose in the liver before it gets circulated throughout the blood. But once that glucose gets into the bloodstream, the pancreas will release insulin, and it essentially tells the cells to take in the glucose, which would lower the blood sugar because it's moving from the blood and into those cells. Now there are some exceptions to certain cells that don't need insulin to actually bring in glucose, and that is exercising muscles. That's a big example. So when your muscles are exercising, they can actually bring in glucose without insulin. So it's kind of cool to think about. So exercise has a lot of benefits to helping lower.
In a play, why exercising helps lower like prediabetes, or like if you have type 2 diabetes?
Yeah, so in that exact moment, it will lower the blood sugar, but actually it's the overall long-term metabolic effects that exercise has on type 2 diabetes or pre-diabetes. Part of it, what happens with diabetes is it's really so different from type 1 actually, and it's more of a metabolic issue, where type 1, it's an autoimmune disorder of the pancreas, where those cells that produce the insulin get destroyed. When you have type 2 diabetes, your pancreas does produce insulin, and it'll initially produce a lot of it. It's almost like trying to scream at your cells, take in the glucose, but the cells become desensitized or insensitive to the glucose. And so there's a lot of theories behind that. Visceral fat gets blamed a lot for it because they can release certain chemicals that might make your cells less sensitive to insulin. But what happens is when you start exercising a lot, you kind of start resetting your metabolism in a way and kind of getting your body to utilize glucose, fats, and proteins, the macronutrients, how it's supposed to. When you have type 2 diabetes, your body's kind of not utilizing those macronutrients as it's supposed to. That's kind of our quick Reader's Digest version of type 2 diabetes. Yeah, it's a really interesting condition from a science perspective. Obviously, it's not fun for a patient, but I've had patients who have gone into remission by exercising, losing visceral fat and stuff like that, changing the diet, because the diet's part of that as well, and it's pretty crazy. I've also had patients who have had the stomach surgery, and so they've lost weight that way, and they've put their diabetes into remission. It's really interesting, because they won't say like cured your type 2 diabetes, even though all your blood markers improve to like non-diabetic levels. They say it goes into remission. But any other questions on the pancreas from the endocrine side? Because we still have to get to the exocrine side. So there's other cells in the pancreas that secrete pancreatic enzymes, and there's all sorts of different pancreatic enzymes. Like, for example, sucrase will break down sucrose, which is table sugar. Lactase will break down lactose, and so there's different enzymes that can break those down that are running through the duodenum or the duodenum. And so there's a duct that the pancreas will dump those enzymes through. It'll join the common bile duct, dump those into the pancreas, and the liver will dump bile into there. And if it's a really fatty meal and the person has a gallbladder, then the gallbladder will also squeeze and push extra bile.
If you've lost yours, then you don't have that.
Yeah, you don't have that extra reserve, if you will. Now you can still break down fat if you don't have a gallbladder, because you can still produce the bile, because that's what the liver does. So if we go here and we take a look, if you can see my finger tucking under there.
Yeah.
So I'm going under the transverse colon, which we'll get to in a minute, but still here's part of the duodenum. I just learned as duodenum. I've broken our treaty when I was going to say duodenum. But if I move this out of the way, here is the jejunum. Now what's really crazy about this, I remember learning this as a student, and when I first saw this, I'm like, this is just like a bouquet of guts. I don't know what to do with it. I know it's the small intestine, but that's kind of like, I was really intimidated by it. But remember, it is one long tube. So if I put any of you, and I have you grab right here, and you go left or you go right, you're just going to end up at the beginning or the end, depending on where you go. And so since I've done this before and I know where the jejunum kind of emerges here, I'm going to do it. We're going to be a little stubborn and go through this here. Look at this. One long tube. I'm going to pause and just show you the mesentery up to the light, because we didn't actually specify this, but in the duodenum, are we doing digestion or absorption?
Digestion.
We're still digesting, but we're starting to absorb more and more as we get further down. So you do absorb in the duodenum, but with all those pancreatic enzymes, the bile going in there, we're definitely still digesting. But now that we're in the majority of the small intestine, the jejunum, and eventually going to make it into the ileum, why are these so long? Because we want to absorb as much of that Oreo cookie as we possibly can, and because we can see all those blood vessels. This yellowy tissue that you're seeing here that connects the small intestine to the back wall is the mesentery, and all those blood vessels in there are going to absorb those nutrients. Now we can't see it on this particular digestive tract because I haven't cut into it, but on the one we string out at the end of class, if you want to, I have cut into it. You can see the circular folds, and you can't really see them, but if you felt it with a bare hand, it might feel slightly velvety, because on top of the circular folds, there's those microvilli on top, so those further increase the surface area. So we have folds to increase the surface area, length to increase the surface area, and microvilli to increase the surface area. Because, as we said, that Oreo cookie has lots of nutrients in it that we want it all, right? But as we go through here, we're absorbing this Oreo, we're definitely in the ileum by now, absorbing, because we're here at the end of the ileum, and then we go to the cecum here. And between the ileum and the cecum, there's a nice little valve called the ileocecal valve. Great valve, right? And so once we pass from the ileum into the cecum, we're now in the large intestine, and we can start changing it from chyme to, we're getting to what we call 4-letter words like poop, crap, swear words, or we can be a little more professional like feces or something like that, but that's 5 letters. But we're starting to get to stuff where we're not really absorbing a lot of nutrients anymore. Now, one thing I do want to mention here, but again, just to clarify, once we pass through that ileocecal valve, it's a one-way valve. We don't want it to go back where it came from. Now, with my patients that I'm working with in the urgent care, I'm obviously a little biased to anatomy. I think everybody should know anatomy inside and out if they're clinicians, but that's just me. You should do an abdominal exam. Like, you should actually touch and palpate their abdomen if they come in with abdominal pain, especially if it's an emergent situation. And I even listen to see if their bowels balance, or if they're overactive, underactive, or if they're just right. There's a lot of Goldilocks principles in medicine. But when I'm feeling around, and I really appreciate this with massage therapists, at least I really tried to push this with my massage students, is I want you to have a non-creepy version of X-ray vision, because you're touching muscles, you want to find, if you find a bony landmark, you can find so many muscles on the scapula, for example. But right here, I will palpate the ASIS on almost every patient when I'm doing an abdominal exam, because I know if I just go a little bit in, like an inch, I'm right at the cecum. And especially if we're worried about something like this, where's my probe? You can see right here, that little pesky appendix right there. Look at the size of it. It's only the width of like a round shoelace and like this long. That's the appendix.
So much problem.
Yeah, and one of the interesting things is everybody realizes this is still a hollow tube. Even though it's small, it's still hollow. And remember, we're dealing with essentially feces or fecal matter in here. Now, appendicitis, what can happen is feces can get in there and kind of get stuck and clogged. And the problem is if it stays in there, it can start to harden. And they call it a fecalith. Lith means stone in medical terminology, so like a hard piece of poop, essentially. And then bacteria can get in there and fester and cause inflammation or this infection, and we call it appendicitis, and it could start to swell like the width of my pinky, which, just comparing it to what it normally looks like, that's a big stretch right there. And if it continues to stretch, what are we worried about? Rupturing, right? We have the cecum here, and then we have the ascending colon coming up right there, if you want to see that. Here's the ascending colon. And then we have the transverse colon coming across right there. Now, because I have the sense of humor of a 12-year-old boy, I have to say this. So 2 to 3 times a day, you'll have what's called mass transit of feces. That essentially these strong peristaltic contractions that happen in the large intestine that move the feces like from one side all the way to the other. Now, sometimes we think it's our stomach talking, but it's actually could be poop moving from one side of your transverse colon. Sometimes, and it sometimes happens when you anticipate eating food, because your lower digestive tract's like, we gotta make room, move things along. I mean, everything can make noise, but there's literally a couple times a day where the large intestine just moves poop really quickly across. Now, it's constantly, it has that low level peristalsis all the time, but there's 2 to 3 times a day where it's like, we're moving things quick. Yeah. But, so, yeah. Yep. People talk about that with coffee. They start their coffee and they have to go to the bathroom. Now, once we move the transverse colon, now let me just show you this here. Now, the transverse colon comes across here, and then the descending colon's a little shy. It's nicknamed a retroperitoneal organ because it hides out behind that peritoneal sac right there. but you can actually feel it if you put your fingers down right here. But you can see it emerge as the sigmoid right there. So descending colon will be right here, and then we've got the sigmoid here. Now, again, because I have a 12-year-old sense of humor, next time you guys make a deposit in the toilet, if it's a large stool and it has a curve to it, be proud of yourself. Because you didn't just clear the rectum, which is straight, you cleared up a little bit into that sigmoid colon, so good job. And then we have, so the sigmoid colon goes down to the rectum and then the anus, and then we release what's left of that Oreo cookie. So what is released from the Oreo cookie, essentially, everybody? First, let me jump back. What does the large intestine do besides move the feces along? Absorbing what?
Water.
Last part of water and salt, essentially, right? Last part of water and salt. And then it is a storage organ. Yeah. And so this can happen a lot with little kids if they hold their poop and it just stays in this area right here. It can pull more and more fluid out of there, which makes it harder, which can create constipation. And so there's a lot of different causes of constipation, but just holding your stool a long time can cause constipation because you're just drying it constantly, pulling more and more fluid out. Now, the opposite can sometimes happen when your body has this diarrhea, something's upset it, and it causes this flushing, and we don't absorb enough water, or it actually literally is trying to flush the pathogen out, and we have all had that wonderful experience where it feels like,
Is that why they say drink more water, get diarrhea?
Well, so that's a great question. Yeah.
Maybe that was just my mom.
No, that's not incorrect. It's just for a different reason. So we all want to be hydrated. I tell patients to drink, it's really funny. I tell patients to drink plenty of water with constipation and with diarrhea, but for different reasons. For constipation, just having that more water can sometimes possibly make the stool a little bit softer if you have more water content in everything that's moving through the digestive tract. Obviously, fiber is a big part of that as well, but that would be the reason for saying drink water with constipation. The reason why we drink water with diarrhea is because the body is flushing it out. You're losing more water with diarrhea, especially if you add vomiting to the mix too. So a lot of times we'll add like electrolyte beverages, like I'll even have adults take Pedialyte, which is typically like a pediatric drink with electrolytes and fluid. Or sports drinks can have that too. But those are two reasons. You tell people to do it with both, but for two different reasons, if that makes sense. So we know what the function of the large intestine is, but what is left? What are we putting in the toilet, essentially? Pretty much everything we couldn't absorb, right? And in our minds, it's a waste product. And so like fiber, we can't really absorb. So fiber is just kind of this roughage that helps push things along. And so anything we don't absorb through the gut just makes it to the toilet. So all those major nutrients from the Oreo, like the carbohydrates, the fats, maybe they have a little bit of protein. I haven't checked the nutrition label in a while, but got absorbed. But anything we couldn't absorb just ended up in the toilet. But I want everybody to have a moment here, because what type of muscle tissue is in the wall of the intestine? Smooth muscle, which is involuntary, right? It's hooked up to the autonomic nervous system, so we don't worry about having to contract it. Can you imagine that Oreo's moving through and you're having a conversation and you're like, hold on, I got to get it around this corner of the jejunum here, and you're like shimmying around, like doing your thing. But luckily, we don't have to think about that. But I want everybody to have a moment of silence, be very, very grateful that the very, very beginning of the tube and the very, very end changes to skeletal muscle. Could you imagine if your external anal sphincter was smooth muscle? You just go whenever it's like, imagine that mass transit. It's like, here we go. So yeah, we'd figure it out, I guess, as humans. But the idea is that external anal sphincter is skeletal muscle. Because here's what happens. It's really cool. Your digestive tract is very sensitive to stretch. There's stretch receptors in there. So when we have that mass transit or we move feces down there, it pushes into the sigmoid and the rectum and the anus, and it stretches. And those stretch receptors send a signal to the brain that says, hey, time to go, and you have a choice. You can either go to the bathroom or you can clench down harder on that external anal sphincter and wait till later, right? We know there's some limitations to that in certain cases, but that's essentially, everybody, our digestive tract from mouth to anus. Does anybody have any question?